Hey everybody, welcome back to Everyday Journey. This is project determination video. I'm not sure what it is right now, probably 10 I think. And we're just going to go over some of the stuff that I'm doing with this Arduino to let you know where I'm at with things. I think I'm having an issue with, or I had an issue that I was trying to figure out what I wanted to do exactly. How to connect this motor to these. These are the windows that I pulled out of that little camper, and the issue I have is that trying to connect something to this was going to be a little difficult. I had to make some kind of adapter to be able to use. I was going to use this motor that came out of the window for the car that I showed you guys, and I was going to use that, and that's the reason why I got a specific kind of a driver for this motor specifically, because it draws so many amps. But I think, given the fact that I don't have a way to easily make that adapter, I'm going to go with something a little different. And by different, I mean this different. These right here, I ended up buying well, basically somebody's entire garage full of stuff one time. And that came with a lot of crap, to include stuff like this. These are old drills, 14.4 volts Craftsman drills, and these, without the batteries, they're kind of useless. And the batteries, of course, they're all crap. They're old, and to get replacement batteries for this probably cost about as much as getting new drills. So what do? Well, I can use these. I should be able to use these anyway to power these things, and they already come with an adapter right here. So if I can get this on here and tighten it up, then there's my adapter. As long as it's tight enough, it should be able to clamp on there. Let's see. There we go. So now, as I turn it, it will turn and operate these louvers. So that's what I think I'm going to do, and that's what we're going to play with tonight. Now I will show you this. This is, I've already replaced all these louvers in here. They were glass, or they are glass, and I only have one of these crank handles, but I've taken this apart and I've lubed everything up real well, so that this one right here operates fairly easily. It's still a little awkward because this whole frame flexes, but it won't really flex when there's a motor on here that's just torquing directly on this. It's not actually trying to push it in all directions. So, but this is a lot smoother than it was. Take this off of here and see if I can get this other one up here. Hopefully without breaking everything. This is the other one that had actually working, where all the louvers were good. The other one I had to steal the glass panels from other windows to be able to make it complete. So this one is a lot tighter. So most likely I'm going to have to take it apart and do the same thing. Just lube up the rack and pinion that's going on with this. But it's not too bad. We'll see. Maybe I won't do anything to it. At least taking it apart anyway. I may still lube it up. But so there's that. One of the first things I want to do is actually get my power for the Arduino. As you guys know, tried to use this battery here. This is a 12-volt battery. Arduino operates off something like 6 to 9 volts. So hooking this up to it, it may work, but it also may overpower everything. First thing we need to do is break out these buck converters. Open it up. I haven't tested it out yet, but these, I got these specifically, and I think I put another picture for these, but I got these specifically because you can adjust them. There's a potentiometer on here that you can adjust so that you can take the input voltage of 12 volts in this case, because I'm using this battery, and I forgot what the maximum is for it, but you can, this has a variable input that can then go to a variable output. So we're going to start with 12 volts and we're going to step it down. That way we can get it down to the 6 to 9 volts that we need for the Arduino. So, and we should be able to see it on the display as we're doing it. Alright, so check this out, make sure we're getting our 12 volts. And 13.93, good enough. Alright. Alright, so that's showing backwards. So, in this case, we should have a positive 13 volts. There we go. So we know this is positive, this is negative. I should probably mark that. Alright. Now we're clearly labeled so there's no confusion later. And there we go, we're already getting power. Now there also were other ones of these that would, what did we say we had? We said 13.9, so 13.7 is what it's reading. I'm going to say close enough for now. The biggest thing is just verifying everything with the multimeter. So, but the other, this is so you get a good reference. I could have used these other ones that didn't have the display and all that. They were a little bit cheaper. But I wanted to make sure I got one that did have the display on it so that I could, when this thing is wired up completely in the end, I'll be able to tell what voltage that's reading. And if it's not exactly right, I'll have tested it enough times that I know what the variation is. So let's say it's saying 13.7 and I know this is 13.94, and the output, I'll adjust the output and it'll show what I want it to. Right now, it looks like it's showing 13.1 for the output. So we need to verify that. I should be able to connect the multimeter directly up to this. I think the leads are probably small enough that I can be able to connect it up into this, and I can get a reading as I'm doing it. I say that, but maybe that's not the case. There we go. It might get a little hairy in a second. I'm not sure if these leads are going to get in the way of each other. I think we're going to have to use a wire instead. I prefer a wire just like this one because it's got the nice solid copper lead. But I'm not sure exactly where I got that from. Thought maybe I'd have a remnant laying around here, but I do not see it. So whatever I did with it, I probably put it away, which is kind of unlike me. Well, that's interesting. Okay, how about let's just do this. Let's rob it from here. since we're doing it over again, we can check it. So that's backwards. That means this is negative. This is positive. There we go. Alright. So we're going to label that. Double check just to make sure. Alright. So, let's wire this back up real quick. Alright. Now let's take this, strip the ends, and we're just going to wrap them around the leads. I know this is a lot to do for just a quick test, but I really thought it would go a little smoother than this. Oh wow. I am surprised that, I mean, it shouldn't matter, but I just took this thing up backwards. I mean, it does matter for operation. What I'm surprised though is that it actually lit up to begin with. Yeah, so luckily these things are cheap. It's still not something I want to burn up right off the bat. I mean, they literally only cost a few dollars, but still. Me, I'm sitting there looking through the camera and I'm thinking, you know, this thing's upside down and that it's okay. Basically just temporary confusion because the fact that this thing is upside down and the way the camera's filming. Alright, so let's get this thing hooked back up. And there we go. So let me show you how to adjust this thing real quick. Let's see which is which here. Alright, so that's positive, negative, we'll do it like this. So I'm getting 13.89, 13.8 or 13.7 on this. All we gotta do is go to this potentiometer. And I believe if we tighten it, nope, we need to go the other way. So we loosen it and it'll lower itself down. I'm gonna believe the multimeter, even though it's a Harbor Freight multimeter, I'm gonna believe it more just because I just trust it more. What we're going for is something under 9 volts, in between 6 and 9 volts, and I think I'm going to go with about 8 volts. And just under 8 volts just under, and they're pretty close. Let's see if we can raise it just a tiny bit. There we go. Multimeter says 801. I'm going to call that good. So we know we're adjusted right. So our input voltage again, and this just switches back and forth, 14.2. And if you hold it down like that, it actually will go off. That way you're not using any more power than you need to for this. It still will show, yeah, it still will show a LED light lit up like it does. But at least it's only one LED instead of everything there. So now this is using the least amount of power it can, as long as that LED is on there. So we're good on that. The real question now is, will this run my Arduino? So let's go ahead and undo these wires. Actually, I guess we do need one of those wires. I didn't realize I had what I had here. Need it attached to here, which is our negative wire. And then we'll take this positive and actually attach it over here. If the Arduino powers up, we know we're good. And there it goes, it's powering up. Got our motor working and everything. So we are good to go. Of course, this would be wired up a lot better later, but that's showing you we can actually use the Arduino powered up to the battery through this buck converter, which solves problem number one for us. So we don't need that connected anymore. Let's go ahead and undo this, and as we do this later, we'll actually wire it up more permanently. So that's just a test to make sure everything's working. Buck converter works, Arduino is working off of it, so we're good to go on that. Alright, so back on this. What we want to check now is we want to check these. Like I said, these are 14.4 volt Craftsman. They're Craftsman. Yeah, Craftsman drills, and we need to make sure that they're going to actually work, because if I want to use these to connect to that, then I'm going to have to make sure that the actual everything powers up. So let's go ahead and break out the drill, and I'll go ahead and show you this too. This guy. There we go. With both of these taken apart, you can look and see they're pretty similar. You got where the battery connects up. You got the, I don't know if you call it potentiometer, but as you push this in, it's going to read a different amount throughout and make it go faster or slower depending on the position. Then you have your forward and reverse, which is right here on both of them. And I can't get that one to go, but you know what I'm saying. There it goes. So forward and reverse. And then a little different right here. I believe this is just I believe this is like a MOSFET, and it's attached to this to keep it cool. This I think is integrated. I think it's right here, and it's just wrapped around all this. And then you got your motor, you got your gearbox, and then of course your selector so that you can select the clutch, and then your chuck. So what we want is all of this right here. Now let's see if they even work. So these are 12 volts, well 14 volts. We can see our connectors have red on the bottom on this one and black on the top. So we're going with the ground on top, and let's see, and a positive on the bottom. Let's see if it works. And so far nothing. Let's see. Make sure we got a good connection down here. There it goes. And as you can see, the more I push in, the faster it goes. Which is nice, I do like that, but I have no way of controlling that with the Arduino. At least I don't, because I don't know what I'm doing that much. Let's see about this one here, make sure it works. And we got the same thing, positive on the bottom. Alright, so that one's working too. Here's our problem though. This has a manual switch here to go forward and reverse. And I'm going to need this thing to be able to switch the polarity on the motor itself so that things can go forward and reverse that way. And I don't need the speed selector. So my other thing is, all right, how do I work this out? Well, how about we just take the motor itself, and now just remember that one was the, there we go, the top one there, that was the ground or the negative. So now we have everything separate. So if we hook up the bottom one as positive, just trying to get this thing where it'll stay. There we go. So we hook up the bottom one as positive, top one is negative. It's going, and it's moving quick, which is not ideal, but we probably can change that by varying the voltage. So let's switch it though and do the negative on the bottom and positive on top. And there it goes. It's going the opposite direction. So they both should work in that way. Although here's my problem, is this thing right here is going to be difficult to mount to anything because of the way that it is. So what I'm going to do is I'm actually going to leave it, and I'll show you this other one as a reference. Let's disconnect this, I can get it safe. So I'm going to disconnect all of this and just have the motor connected up to power. That way I can do my controls, varying the voltage, which should make the motor go slower or faster, and then varying the, changing the polarity so that I can make it go forwards and reverse. So that will be connected there. All this can go, doesn't need to be in there, but I do want to keep the housing though, because let's see which one this is. I believe it's this one. The housing is something I can use because it's going to keep the motor stable. And then if I need to, and I probably will, is I can take like a 2x4 or something like that and put it against here, drill a couple of holes, screw it to it, and now this is secure and this is attached securely to what it needs to attach to. I think that's the way I'm going to go. It's not going to look the best, but I don't care. As you know, I just care about function over form. It doesn't have to look great, it just has to work. Now later on, if I feel like it, I can make a proper mount and everything for this. And if I wanted to even, I could then make an adapter, or I could even use the other motor for that matter. but this is just to get something working. So this right here, these should work just the way they are. I just need to strip out the components I'm not going to use and just use the motor and the gears. One thing I will need to do is make sure that I have these selected for the clutch. Have those selected to the drill position, which in this case would be like right, well, yeah, be right there. So that there would be very little, if any, slip in this, because I don't need this clutch to function. I want it to be just direct drive. Well, there we go. We now have power to the Arduino, which is one thing I needed. We now have a motor that's going to work, and then we have a way to connect the motor to the window frame so that it will actually operate the way it needs to. Now, things I have concerns about. I have to figure out how I'm going to switch the polarity, but I believe that should be just normal stuff through the controls with the Arduino talking to the, let's see if I've got it here. And this may not be the one I use, but yeah. So the motor controller, the Arduino will just talk to the motor controller, and it will be able to switch that forward and reverse as it needs to. Now, I do need to work on a limit switch of some sort, and that I can do one of two ways. I can either, one, use a limit switch, an actual limit switch, so that as the window opens, something comes up to the switch, and when it gets to that peak moment, it trips the switch. And therefore, it can't go that direction anymore. It can only go the opposite direction, and that will then rebound back to its normal position as it goes. That's one thing. The other thing I can do is possibly put it on a timer. You know, I can figure out how many revolutions I get with this per second or whatever, and then figure out how many revolutions it would take to get the window to open fully, and then figure out how many revolutions that does, or this does, within a certain amount of time. And that makes it to where I could then only run it in that one direction for a certain amount of time, preferably less than what would make it crash. So as it opens up, it'd be like, all right, it'll only open up for 2 seconds. It'd be like 1, 2. It could go this far, a little bit more, without actually messing things up, but we only need it this far. And then you can have it go just the opposite. And that's okay, except for there's no safety guidelines in there. If it did go just a tad bit longer, or if each time it operated, it went a little further than what we thought, well, it can eventually build up to where it ends up coming all the way to the full position and further. We don't want that. So that's where that putting the limit switch would really work. So, but we're good to go. Just have to mount my windows, well, they're louvered windows. I have to mount those in the greenhouse. I have to move my my solar panels and battery all up to where the greenhouse is at, and then I have to install those windows and then install this on there, and that'll get me to a certain point where I can actually operate it, and then I can start working on the literal controls of it. So that's really all I've got for the moment. As you can see, it's kind of a slow process when you're not dealing with off-the-shelf stuff, but you can make it happen. And since this is not any priority, it doesn't have to happen right now because spring has already happened. The only thing I really need to do is just make sure my plants are good and I don't cook them. But I can go out there and open things up myself. As long as temperatures stay about average, we're good. If they get too high, then that's where I have a problem. That's where I need some fans and things like that. So hopefully I get to getting that before it really gets extremely hot. Now, by extremely hot, I mean something like this right here. And I've got pictures, I believe, got pictures to show you where this greenhouse already, in one day where it was windy, I didn't want to leave it open. And what I've been doing is just having the door open. And prior to that, it was a little cold in there. So what I was trying to do is, one, keep the greenhouse closed up so it wouldn't just blow away, because it works better when it's closed up. But two, I wanted to keep it closed up to warm it up more in there, because it was extremely cold right before that. Well, this day we happen to have 62-degree weather. You wouldn't think that's really all that bad. That's 62 degrees Fahrenheit. But it was sunny, and whenever I went out there to check on things, it was 110 degrees in there. So literally would have cooked all my plants if I had any in there at the time. Luckily I had some I was pulling out, and so it wasn't an issue. But that's the stuff we're dealing with. It can get even hotter than that in there. But once it gets over a certain temperature, it's going to cook everything. And that's what we're trying to avoid. That's the reason why automating it, because it's just like they say with having a child or an animal or something like that inside your car during a summer day, it can heat up extremely fast. And even if you left the car running, if the car ran out of gas, I mean, it's gonna then stop running the air conditioner and it's just gonna heat up really, really fast. So that's what we have to do. The camera here is turning off, and I'm done at this point. So if you like what you see, comment, subscribe, all that good stuff. And until next time, y'all take care.